In this lesson, we are going to review some basic probability concepts. To start, just as a reminder, if an event is guaranteed to happen, its probability is 1. Sometimes you'll think of that as 100%. A lot of times we can't guarantee most things, so you're not going to see that come up very often, but an example of that would be, I could say right now that it is a 100% chance that I will have a son. Basically because I've already had a son. So it's already happened, so I'm going to say that now. You don't hear a lot of people making predictions about 100%. The same thing is if an event can't happen, its probability is 0. So there's no chance of that happening. Again, it's not very likely that we're going to use zeros very often, but they could be the case. Mostly, though, all probabilities lie between 0 and 1. So when we use them as a percentage, it'd be 0 to 100%. Or the decimal values for those, and you'll see lots of different ones for that, as you would probably already know. And then the probability of something not happening is 1 minus the probability of it happening. So for example, if the meteorologist says there's a 30% chance of snow tonight, the chance of not having snow then is 70%. So they counteract each other and they would add up to 100% total. So just to go through some basic ones, if you roll one die, what's the probability of an even number? So let's think about a die. We've got the numbers 1, 2, 3, 4, 5, and 6. So the probability of an even number, if we're going to write that as a fraction, there's 3 of 6 even numbers. So we would say 3/6, or reduce that to 1/2. Probability of 3 or bigger, there's 4 of those, so we'd say 4/6, or 2/3. Don't you feel like you're doing some basic probability? Here the example is not a 4 or 5. So not a 4 or 5 would be every other number. So in this case it'd be 1, 2, 3, and 6. So you could say there's 4 numbers that are not 4s and 5s. Another way to look at that would be to actually say that since there's 2 numbers out of 6 that are 4s or 5s, we would do the probability not. So we'd subtract and get 4/6. Either way, however you want to think of it. And then the probability of an 8, here's a good example of when that's not possible since we're talking about a standard die. So our probability of rolling an 8 is at 0. Now we're going to talk about a deck of cards. I have learned from my years of teaching that some students don't play cards. And so I want to just run through what's in a deck of cards because we'll use cards a lot for probability this chapter. And really anytime you talk about probability, we use cards quite a bit. So just as a rule of what's in a deck of cards, we have 26 red, and then you also have 26 black, so you have a total of 52 cards in a deck. The black suits, they're called. The black suits are the spades and the clubs, and I'm going to draw these as best I can. There's my clubs, and there are 13 of those, and then there's 13 spades. And then our red suits are diamonds and hearts, so we have 13 hearts and 13 diamonds. You'll notice this said no jokers in there, and so when you're looking for a deck of cards, what you would have in there is the numbers 1 through 10. Well, I'm sorry, not 1 through 10. Let me start that again. How about 2 through 10? We'll say through 10. 2 through 10, all of those numbers, plus a jack, queen, king, and ace. So here the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 9 numbers right here, right? And then the 10, 11, 12, 13 with the jack, queen, king, and ace. If anyone's ever talking about face cards, those are my face cards. So if you hear anything about that. So now let's do some probability stuff. So the probability that we had a black card. Since we said 26 out of 52 are black, you would write 26 out of 52. And then we're going to reduce that to 1/2. And we realize half the cards are black, half are red. The probability of it being a 7 and a heart. So really what they're looking for here is the 7 of hearts, that exact card. There's only one 7 of hearts in a deck. So it'd be 1 out of 52. A red club, and if you notice I said clubs were black, so we have no chance of having a red club because clubs are black. And then the probability it's not a face card. Well, face cards we said were jack, queen, and king. So there's 3 face cards per suit. So per suit there's 4 suits total, which means there's 12 face cards in a deck. So if there's 12 face cards in a deck, that means all of the other cards are not face cards. So 52 minus 12 is 40. So we'd say 40 out of 52 cards are not face cards. And if I reduce that, I would get 10/13. Hopefully that gives you a little bit of review on probabilities and how to write those. This is now, we're going to start working with a chart. So if we were given some data, and you'll see that we have separations here of people who went to Valley Fair. So we have kids, adults, and then totals, and then male and female. So if they want to find the proportion of people who were male, we're going to look at male, and we're going to look at our total. 1,522 people were male out of the total number of people, which is 3060. And if you want to reduce that on your calculator, remember you can take 1522 divided by 3060 and then hit enter, and then you go math, enter, enter, and it'll reduce that fraction for you. Which it does end up just dividing by 2. So there's my reduced fraction. And then the probability that we have a kid. So we look at how many kids we have total. So that'd be in a different spot, right? Here's my total kids. And I'll divide that by my total of everyone. So I'd have 1963 divided by 3060. And that actually ends up not reducing. So that's as far as I can go. These you will often calculate conditional probabilities off tables like this, and that's something that we work with a little bit in AP Stats, and tiny bit we'll work with in this chapter also. And then the last one is an adult female. So what I'm looking for first is just females that are adults. So I have, if I look at that, I have 502 right here. See my females who are adults? And then since it's talking about, it sounds like the whole population still, right? So it'll be out of the 3060. So I have 502 adult females out of the total number of people. And when I reduce that, I get 251 out of 1530. So that's me doing some probabilities based on a two-way table. Next, you'll see that we have a pie chart. And mine's color-coded a little better than yours, but hopefully you can see the shadings. Before I do any probabilities on pie charts, I think it's really smart to just list what you know. So for example, and we're not trying to trick you with this, so don't measure everything out and check. I'm going to say that this is 1/4 of the pie. Would we all agree with that? And I see that this is another fourth right here. So when I'm looking at these two spots right here, it looks like I could say this is 1/4, but it looks like they cut it in half, right? So it'd be half of a fourth, otherwise known as 1/8. And then when I look at my last fourth right here, they divided that into 3, it looks like. And it's a little bit off. I think if you look at it, you can see it might be a little bit off, but it's, again, we're not trying to trick you. So if I take 1/4 divided by 3, I would get each piece here to be 1/12. And I think labeling these pieces of the pie before you even start the problems is going to help you. So when I look at letter A, what's the probability of it being a yellow slice? So I would take my probabilities that I have. I see I have a 1/12 and a 1/12 that's yellow. So we'll go ahead and add those together. And then if I reduce that, I get 1/6. What's the probability that it's white or yellow? So my white ones I see are 1/4, 1/12, and 1/8. And then my yellow I just did, right? That's 1/6. So when you add all of those up, you can find a common denominator, you can put them on your calculator, whatever you do, you should end up with 5/8 as the total. Then, when I do the probability of not white, there's a couple ways you could do that. You can calculate the white and then subtract 1 from that, or take 1 minus that probability. Or you can realize if it's not white, that means that it's yellow or purple. So I'm going to go ahead and add my yellows and purples together. So my yellows are 1/12 plus 1/12. And my purples are 1/8 and then 1/4. So when I do that, I would find my probability to be 13/24. Hopefully that makes sense for a quick little review of probability. You'll have a worksheet and an objective tomorrow, so let me know if you have any questions.